Hi everyone. We have built an enhanced CI/CD pipeline for web API development and would be presenting a final demo. So what is continuous integration, that is CI, continuous delivery, that is CD, and continuous testing, that is CT? Continuous integration helps to ensure that the software components are working together. In CI practice, developers build, run, and test code on their own workstations before they commit code to the version control repository like GitHub, GitLab, etc. After changes are made to the repository, a chain of events is set in motion. A typical first step in this chain is the creation of the latest version of the source code. If the build is successful, the tests will be carried out. And if testing is successful, the build is deployed in testing or staging environments. The team is notified of the status of this process and is provided with a report with details such as build number, defects, number of tests, etc. Continuous integration helps ensure that the software is fully integrated. If any of the steps fail, integration may stop, and the results will be reported to the team so that they can take a necessary action and fix the defects. Continuous delivery picks up where continuous integration is over. While CI is the process to build and test automatically, CD deploys all code changes to the testing or staging environment in the build. CD enables builds to be released to the production environment when needed. Allowing the team to deploy on its own, the CD effectively reduces time on the market. Simply put, continuous testing is a software testing type in which the product is evaluated early, often, and throughout the entire continuous delivery and continuous integration process. Continuous testing uses automated tests to ensure teams receive immediate feedback to quickly mitigate as many risks as possible throughout the software development cycle. Team members are able to continuously learn about the product and what can be done to increase quality and reliability. Few benefits of continuous testing are finding errors on time, testing early and often, accelerate testing, and reduce business risks. So what was done before? The previous team had already built a CI/CD pipeline, and we enhanced it to a CI, CD, and CT pipeline. They allowed adding and running of only unit tests in the CI pipeline. They also allowed easy installation and configuration of the pipeline using CLI. They made sure every push or commit made will go through a CI/CD pipeline and all the tests must pass before deployment. They allow the deployment of the application and test only on OpenShift and inform the developers if there were any build failures. So the MVP or minimum viable product that we had decided on had the following features. We added integration tests and load tests in our CI pipeline. We also created a staging environment in Google Kubernetes Engine to perform application testing. We made sure that if the build failed or test did not pass, the application cannot be deployed to the production environment. And we also made sure that the application and production environment gets tested continuously.
Here is the CI pipeline. So in the diagram, when developers make any changes in the code and the commits are pushed to GitHub, GitHub Actions trigger the CI workflow. It builds the project with the changed contents, formats the code, and runs unit tests with PyTest and Selenium, and then provides the results of the test in the pull request. If the changes introduce errors, the developer can go back to debugging. If there are no errors from the tests, it is deployed to Kubernetes in the testing environment. Once it gets deployed, integration testing will take place and check marks will appear on the GitHub Actions page if the tests have passed. The change is ready to be reviewed by another team member as a pull request. When the team member approves the changes, the code will be merged with the main branch, and this will trigger the CD staging pipeline. Once the code is merged, GitHub Actions will push the merged code to the staging environment and will be deployed to Kubernetes. Now the entire application will be run through integration and load test. If the test runs successfully, corresponding check marks will appear and the code will be ready to be deployed and or pushed to the production branch. Once the code is ready, the staging environment will be cleaned. The CD production pipeline will be triggered once a release of the application is created. The workflow will be similar to our staging pipeline, except that now it's being deployed in a permanent environment. Continuous tests will be run using an API scheduler, and the test logs are collected by FluentD. So FluentD is a data collector that we'll set up on our Kubernetes nodes to collect log files, filter, and transform the log data, and then deliver it to the Elasticsearch cluster, where it will be indexed and stored. These logs will be displayed to the user using Kibana, which is a dashboard for Elasticsearch.
During our pipeline design, we made two key decisions. The first decision is to deploy the tests and application on Google Kubernetes Engine. We have several reasons to choose GKE. First, Kubernetes was originally designed by Google, and GKE has the best support for Kubernetes. Second, GKE provides a lot of tools to help us deploy apps directly from Google Cloud Platform, and it is more intuitive to use. Thirdly, we can easily find the docs of deploying to Google Kubernetes Engine using GitHub Actions. The next important decision we made was we decided to write documentations to guide users to write their own YAML files instead of developing the CLI tools to generate the YAML files. The main reason was flexibility. As this is an open source project, if other developer wants to use our pipeline, he can take our docs as a reference and write his own config files to deploy and automatically run other kind of tests. Another reason was we don't have enough time to develop the CL tools, as we have at least 17 YAML files in total. And we decide to put more time in exploring how to view the logs in continuous testing part in CD pipeline. Next part, Yiqian will introduce the overview of our sprint.
Now, I will take you to each sprint to introduce our progress. In the first sprint, we configured the previous code base, deploy a code change to OpenShift, and discover an integration test and load test. In the second sprint, we manually run integration test and load test on our application, set up the CI pipeline, automate deployment of the Flask app on Kubernetes GCP, and deploy the integration test on Kubernetes GCP. In the third sprint, we automate the integration test and load test in the CI pipeline, creating and setting up the staging environment in the CD pipeline. Also deploy and automated deployment of the application on GKE. In the first sprint, we optimize our CI pipeline to make it way faster than before by removing load tests in CI pipeline. Set up the production environment in the CD pipeline. Deploy and continuously run the test in the production environment. And documentation everything we did so far. In the last sprint, we are able to provide a user interface to display test logs. Also, we tested our pipeline to make sure every part is functional, stable, and verified. Our CI pipeline was built upon BU team's project last semester. They did the unit test and code format part. After several tests, we figured out that their code format doesn't work, so we modified it to format check, and now it works well. Also, we implement the integration test that runs in our CI pipeline. This image here is an overview of our CI pipeline. The pull request triggers GitHub action to firstly do the code format check, then followed by a unit test, and next is to set up, build, and deployment of our application to Kubernetes. After the application is deployed, The integration test will be deployed and run. When all testing is finished, the cluster environment will be deleted to keep the environment clean. If all checks in CI pipeline has passed, as you can see, now we are ready to merge this pull request to our main branch. Next is our CD pipeline.
After we pass all the tests in CI pipeline, the developer can merge the commit in the main branch. Once he clicks the merge button, it will trigger the GitHub action and we will go to the staging environment pipeline. This is the overview of our staging environment. We will create a temporary test environment to run the integration test and the load test. Based on the branch protection rules we set in GitHub, if all the tests pass, we can merge it to main branch. If some of the tests failed, we cannot merge it. Another part of CD is for production environment. It will be triggered by the new release. In our pipeline, we deploy the app and set up a permanent test environment. We can also use the EFK stack to view the logs continuously. This is the result of our first release. Right now, we only run the load test continuously. Another important part in our pipeline is continuous testing. As we mentioned before, CT means perform all types of testing continuously throughout the lifecycle of software delivery. In CI pipeline, we have format check, unit test, and integration test. We use Selenium to support the integration test. In CD staging environment, we have integration test and load test. We use Locust to run the load test. In order to collect the logs, both the integration test and load test run as jobs on Kubernetes. Once the test finishes, we can check the result through multiple interfaces. In the pull request page, we can see the status of checks we run. In the GitHub action page, we can view each test and see the logs in detail. Here are the logs of the integration test. If the test is failed, we will receive a warning email, and we can also check the traceback info in GitHub action page. In CD production environment, we run our load test at 4 a.m. every day, and we use advanced Python scheduler to support this continuous test. Next part, Yash will talk about how can we get the logs of tests in our production environment continuously.
Now let's talk about logging of load test part using Fluentd, Elasticsearch, and Kibana. So here Fluentd will be running as a daemon set to collect logs from the load test pod, irrespective of the node in which it's running. And the data will be indexed on Elasticsearch, where it can be visualized on Kibana. Let's have a demo of this in the local Minikube cluster. The Lotus pod is already up and running locally. As you can see here that the GKE production environment test pod has been created and it's been running. Now let's create the Fluentd daemon set so that it will be able to collect logs from the specific pod. So now let's create the Fluentd daemon set. Yep. As you can see here that the daemon set has been created. Let's check the status of it. And this daemon set would be created in the kube system namespace. As you can see here that Fluentd's daemon set has been created. Now let's go to Elasticsearch and see the list of indices. So here we can see that kublox Fluentd index has been created and the data is present in the specific index. Now let's see the logs in Kibana instance. Let's go to Kibana and create index patterns. So first, to view the data on Kibana, we first need to create index patterns, which maps to the corresponding index on Elasticsearch. So once we create uh, index patterns, we will then be able to view the data on the Discover tab. So now let's go to the Discover tab and see the data. As here, you can see that there are two hits, and if we expand this specific document here, you will be able to see the logs of the load test pod. Um, yeah. So yeah, this is the end result of the load test pod log that it generates. So this is the overview of collecting logs of the load test pod using Elasticsearch, Fluentd, and Kibana stack. The another advantage of this Elasticsearch, Fluentd, and Kibana stack is that we could replace Elasticsearch with another store such as MongoDB, where we can create an API out of it, and that would be another way of displaying logs to the end user. So yeah, that's the collecting of the logs part for the load test in production environment. Thank you.
So the limitations that we currently have are the following. We don't have an isolated testing environment. We need to wait for other people to finish their tests in the environment. The second one would be we also need to automate the logging of the load test, which has not been done currently. And the third one is we need to create a separate test database as the same database is used in the production environment. Coming to the future work, we would like to support other platforms like AWS, Azure, etc. for deployment. And we would also like to include the feature of supporting multiple users to submit code changes at the same time.
We worked on some pretty exciting tech in this project. We learned knowledge and gained some experience on using Selenium to write the integration test, using Locust to do the load testing, using GitHub Action, Google Kubernetes Engine, and kubectl to deploy application on Kubernetes. We learned how to build Docker images, use Docker image YAML file and customize YAML file to automating test, using AP scheduler to continuous testing, and using Elasticsearch, Fluentd, and Kibana to viewing test logins. Also, thanks to our excellent teammates, we all learn and gain experience on team collaboration.
Here is the final burn-down chart of our entire project. We had initially set up an estimated number of points as 150, but we have crossed that mark with 168 points and have completed all the tasks that we had set out to do. As you can see, we have maintained a constant and steady velocity throughout, with an average of 39 points per sprint, and this ensured that our progress was not hindered by any major obstacles. We finally reached the end of our presentation. I'd like to thank Eta, Prajna, Surya, and James from State Street for their constant support throughout the project. I'd also like to extend many thanks to our mentors, Jan and Panat, who helped us get accustomed to the project and provided us with solutions whenever we were stuck or had any doubts. We had a great time this semester, and thank you all for taking the time to watch this presentation.